Okay, sorry, I decided to be problematic and do a demo and had to get my own swapped in there, so thanks for bearing with me. My name is Frances Perry. I'm a head of engineering at MotherDuck, which, as folks mentioned earlier, is a startup based on taking DuckDB into the cloud. And we've got our headquarters just over on East Lake in Seattle, right on Lake Union. So today I'm going to talk about, I think it's all three of your use cases. So it was interactive analysis, pipeline components, and creative architectures. Wonderful. Awesome. All right, we're going to do all three of those today. And so we'll be demoing in particular what happens when you run a DuckDB instance locally in your browser, a DuckDB instance in the cloud, and how you can get some really cool and interactive visualizations along with those. At least that's what the title of the talk says, so that's what we'll do. But PG-DuckDB, which was also mentioned briefly by Mark, is so exciting. We're also going to throw in a brief demo of how that can be used with MotherDuck. And that one will be one of those demos that was working very, very recently, so we'll be living dangerously and having fun with it. All right, so just going back to the beginning a little bit, right? Those of us in this room are probably already believers that their big data is pretty much dead, right? Small data is where it's at these days. But I'll just go through a little background there, even though I'm quacking to the choir. Machine shapes have fundamentally changed, right, in the last 20 or so years. Before I joined MotherDuck, I spent 15 years at Google. And I think the teams I was on at the either end of my career really helped highlight this difference. So when I started, I was working on what basically became the successor to MapReduce. And MapReduce was still pretty shiny and new. The paper was only 4 years old. And everyone was really excited about this concept that if you have a lot of data, you just throw more machines at it. Right, just more and more and more machines. And that's where we were getting our scale and our processing capabilities from. But if you go back and look at that paper, right, those machines had 2 cores and 2 gigs of RAM. Those were some real powerful machines back then in 2004. So we had to use more and more of them. But by the time I left Google, I was working on Compute Engine, and we were just launching our next general purpose VM shape. So not even one of your high performance ones, right? Just one of your standard VMs. So anyone feel like 96 cores and 1.5 terabytes of RAM? Because you can just grab it right down in South Lake Union, right? Easy peasy. And so that really goes to show how computing hardware has changed so very, very much. Even this laptop that I just plugged in, right? It has 8 cores, 16 gigs of RAM, and I'm using it mostly as a glorified web browser. So the technology that we built originally for data processing was built when the world looked really different. And then in addition, back in the day, right, we had this idea that big data was going to be everywhere, and we were just going to start accumulating it and piling it up. And we did, right? There's a lot of data out there, but honestly, when you look at it, we don't use very much of it. Most of the time, we're just processing that small portion of the data. In fact, MotherDuck CEO Jordan put out a blog post last year that says, big data is dead, right? And he laid out some bold claims basically saying, nobody has big data, and we don't need the tools that we've built to process it. But you'll notice my little duck there picketing with a sign is still sad. And the reason he's sad, my friends, is that he's a data person, or a data duck, I guess, and he doesn't have any data to back up Jordan's claims. So luckily for him, pretty recently, our friends over at Amazon Redshift released a paper with a data set in it that covered, I think it was 500 million queries over 32 million tables gathered over a 3-month period, something like that, right? And so Jordan was able to take his wild claims without any data backing them and go look through that data set and see, indeed, most people don't have big data. In fact, he was actually wrong. Where's Jordan? I think he's over there somewhere. He was wrong. It's not the big data 1% that has data. It's the big data 0.00025%, right? Most people are querying data sizes that are really reasonable. Okay, so these 2 things probably aren't new to folks in this room. This is why we're all here, right? DuckDB is really built to thrive in that set of conditions. I just want to highlight, 2 of the things that make us at MotherDuck so excited about DuckDB. One is I believe it's unapologetically single node. Yep, you're not going to apologize. 1 node, my friends, that's all you get, none of this scaling out, right? And yet at the same time, it's incredibly performant. So we can be single node and we can still be performance. So that tweet is somebody who was trying to benchmark DuckDB against some other databases. And at the end, he's like, well, what if I just do it on my laptop? And in fact, he found DuckDB outperformed a 16-core data warehouse, right? So just on that, I think he had a MacBook M1. It was like a 2021 machine. So he got a lot of speed then. And that tweet is actually a little stale. I guess it was a tweet. Now it's an X. I don't know. But it's from 2023, right? And so if you look, even since March 2023, there's been a huge number of performance improvements in DuckDB, and I think Mark was probably just telling us about a bunch more that are coming. So single node, single process doesn't have to mean that you don't get the performance that you need. And then the other thing, also hinted at earlier, is this idea of being able to run anywhere because we have zero dependencies and we're able to embed DuckDB in any sort of creative architecture. In particular, compiling into WebAssembly means that everyone with a major web browser has a version of DuckDB, no installation necessary, right? It's right there, it's pervasive. And that's really something that opens up the capabilities of what we can do with it. So getting to how MotherDuck builds on DuckDB, here is our friendly duck. They are running a web browser with DuckDB in it, compiled into WebAssembly, right? And running locally has a whole bunch of power, right? You're using the cores that you've already paid for. You're getting that interactive speed. It's great. But like, what did I say this was, 8 gigs of RAM or something, 8 cores? Like, I can get 96 cores at Google Cloud, right? So maybe I do actually sometimes want to run off my laptop. Maybe I want to slam the lid and go to dinner and have stuff keep running, right? So having a hosted version where you've got your own DuckDB instance running in the cloud that's able to interact with the DuckDB instance on your laptop. So what MotherDuck provides is basically the ability for every user to have their own instance of DuckDB. In front of that, we add a little bit of basic authentication, sort of sharing capabilities, some insights on making it easier to run and so on. And then the storage layer that we have looks like a local file system, right? Because that's what DuckDB wants. That's the duck's natural habitat. But actually, we're going to store it, in cloud storage with a bunch of differential layers so that we can do things like zero-copy clone and clever sharing and things across the cloud. So there's our duck friend. If you've seen the movie Mighty Ducks, yeah, great movie, ducks fly together, right? That means ducks have friends. And what's the fun of having data if you don't have friends with data, right? Data is really about sharing it and collaborating with other people. So using DuckDB, our ducks friends, their flock here, can all use their own interfaces of choice, whether it's Python SDK, the command line, et cetera. And each duck will get its own compute in the cloud, and we'll dynamically scale that based on what that duck's processing needs are, right? So you're only going to pay for what you use. And then they can all interact and share with that same layered storage behind the scenes. So that's MotherDuck in a couple of slides. But what I really want to dig into in this talk is what we call dual execution. It's basically this idea of having 2 DuckDB instances, one locally and one in the cloud, and having them communicate with each other while you're working with it. So we'll do 2 demos here for dual execution. First we're going to do intro it, then we'll get to the demos. I'm getting ahead of myself. All right, so I've just zoomed in here on our 2 instances of DuckDB. So we've got one running on the laptop and then one running in the cloud. And each of them have the usual steps that a database is going to go through as it's executing your queries. But again, as mentioned earlier, DuckDB has an extension framework. So we have a MotherDuck extension that's running in these copies of DuckDB. And that's able to add and augment the existing phases that are happening. So what we'll do is, during the bind phase, we're going to be able to look across at all the different tables that are referenced and recognize where they are. Are they local on the laptop? Are they in the cloud? Are they in MotherDuck? Are they elsewhere in the cloud, S3, Google Cloud Storage, et cetera? And then the optimize will you come up with a query plan that's able to run different portions of the computation in different places, depending on the data locality. And then finally, coordinate that execution so that we're transferring data at the right places during processing between the cloud and the local laptop. So, for example, right? Here's a very simple AST from parsing a query. We do the bind phase and we notice that first database is running on my laptop. The second one is hosted in MotherDuck. And finally, the third one somewhere else in the cloud. So, somewhere where it doesn't really matter whether we process it from local or MotherDuck. So then the optimize phase is going to look and figure out the smartest place to break that query up. So we'll run a portion of it in MotherDuck, in that potentially larger DuckDB instance in the cloud, and then bring that over and join it with the rest, and do the rest of that processing and the rest of the work on your laptop. And so finally, when we execute, that's exactly what happens. There's a little duck that picks up the data. And it's technically called a bridge operator, but that wasn't as fun a picture. Okay, so that's dual execution, right? This idea that the two versions of DuckDB that are running are collaborating and cooperating to run your data for you. So getting into my demo, as I said, we're going to demo some interactive visualizations that we can do where we're using a web browser and playing around with data using graphs and so on. And then also we're going to sneak in that PG-DuckDB demo because it was just too much fun to leave out. All right, so just again, here's our duck, right? They've got their web browser. That web browser is going to run both DuckDB and also Mosaic. Now, Mosaic is a project out of University of Washington, just north of here, and it's a platform for doing data visualizations on top of DuckDB. And then we've got the DuckDB instance that's running locally, interacting with the DuckDB instance in the cloud. So let's pop on over. Here is, when I disconnected, it lost all the perfect. I had tuned all of these perfectly, my friends. Sorry, let's get these going again. All right, so over here I have the Chrome developer tools, right? And so you're gonna see as we're going what SQL queries Mosaic is actually generating and how long it's taking to execute them. So the first thing I'm gonna do is just a real quick grab my token and log in, authenticate to MotherDuck, and now MotherDuck has a DuckDB instance for me running inside the cloud. So I've got two different DuckDB instances running now. And I'm gonna go and grab one of our data sets, the star catalog. I think it was about 5 million rows, so decently hefty. And what you can see here on the side, these are the queries that are running locally, right? And then they may also be interacting with the DuckDB instance in the cloud. And right now, they're running just enough queries to gather the data to show this initial visualization. And they're taking, on the order of hundreds of milliseconds, something like that, you can see. So now, if I take this mouse and I'm going to hover it over the graph, right? And what that's going to do is let Mosaic know that I'm almost certainly going to start interacting with a data in this portion of the graph. It's going to go ahead and build what it calls a data cube and basically start prefetching and data in a different format that will make it easier for me to interact with. And this is definitely slower than it was from the office and the office's Wi-Fi, but that's all good. So we've got, again, a few hundreds of milliseconds and things happening. But now what we should see is I'm able to get a lot faster speeds. So every move of my mouse, right, is generating a new SQL query. And you can see the other graphs are reflecting the changes that I'm making. And all of this at this point is running locally. So the data set originated and started in the cloud. And what we've done is pulled down just enough data to get that interactive feel. But look, we're at 3 milliseconds, 4 milliseconds. My friend, this is not going out to the internet, right? This is all right here. And you can just see the feeling of complete and utter instant feedback. As I play around. And I honestly wish I knew more about what exactly the star catalog is showing, because I'm sure there's some really fantastic science behind it as well, but that's okay. So, and you can see again, there's some queries that are larger, it's going fetching different chunks of data, but as much as it can, it's running all of those SQL queries locally in my browser using DuckDB. All right, so that's my first demo. But let's get into the second one. So we take our same good old duck friend. I guess they took off their hat, but there they are. Still have that web browser and still have their MotherDuck instance. And now what our duck is going to do is start to gather data about how animals move around the world. Right? Our duck is going to build a nice big database. So if we pop over and go to our Duck's MotherDuck page, you can see Duck has a nice database here on animal traffic. This is where animals go. Animals go to places like fields, forests, watering holes. Sure, right? So we have all of these different data sets, and we're starting to track animal friends. So we'll just take a quick look at our water visits table. I can use Column Explorer over here on the side just to get a nice idea of it. The data looks incredibly bland, as if it was automatically generated by a Python script yesterday. But it could be a lot more interesting, right? But what you can see here is I've got data in my database from 3 different watering holes. There's ChatGPT called them Mango Beach, Emerald Pond, and Crystal Lake. Okay, so 3 different watering holes, and if I look at an individual record, for example, I've got an elephant of the savanna variety named Leo. Looks like Leo visited Mango Beach for an entire second. Okay, so again, data quality could use a little bit of work, but you get the idea, right? So Duck has this fantastic database that they're aggregating from all of these places. However, ducks have good friends. Ducks have friends. Whoops, wrong direction. Elephants. Ducks are friends with elephants. Here's our friend elephant. Elephant runs a particular watering hole called Muddy Hollow. Muddy Hollow is a lovely little neighborhood watering hole full of mud you can wallow in. But as the manager of Muddy Hollow, our elephant here has to keep a lot of data sort of about how Muddy Hollow is working. He's tracking the water temperature hour over hour, the fish population, and all the kinds of visitors that come to Muddy Hollow, right? But elephant doesn't really like DuckDB because he's an elephant. He prefers Postgres. So he's a Postgres server. So there's elephant. They've got a Postgres server, and they're interacting with it from the command line. So we can go over here and see there is elephant's visit, a list of all the folks who've come by to visit Muddy Hollow recently. You've got Ellie the elephant, Huey and Daffy Duck, et cetera, right? So this is great, and an elephant likes Postgres, and it is good. But Postgres really, if you've ever tried to use it for analytics-heavy workloads, that's really not what it's designed for. An elephant starts to wonder what else they could do if they had access to more data and more analytical capabilities. So lucky for elephant, there's something called PG-DuckDB. And as folks mentioned earlier, and Joe will go into this in a lot more detail in a later talk, but this is basically a way to embed DuckDB inside a Postgres server. And so we've got a collaboration here. It's DuckDB Labs, MotherDuck, Hydra, Neon, Microsoft, number of folks getting together to try to make this happen. And from MotherDuck's perspective, the other thing we've added in is a connection into MotherDuck. So now from within basically what we're going to do here is do hybrid execution, dual execution with the 2 different copies of DuckDB. But again, the local one's now running embedded inside Postgres, talking to the instance in the cloud. So if you recall our good friend over here, Duck's data set didn't have any data about Muddy Hollow. So the first thing Elephant wants to do is go and add that data in. So what we're going to do here, there we are, is we're going to insert into that water visits table, which is in the cloud in MotherDuck, DuckDB table, all of the data from the local Postgres database. So it's going to run like that. And you're going to think, oh my God, her demo's broken. It's not. We just actually haven't implemented the counters yet. So, it's broken, but known to be broken. So now, if we pop back over here and rerun this query, we should see that we have 4 pond names in our data set, right? 20% of our data is showing animals going and visiting Muddy Hollow. So what we just did here is take data from Postgres and go ahead and insert it into a DuckDB instance running in the cloud by using a DuckDB instance running on the Postgres server. So that's fun, that's data uploads, but that's not really, that's cool, but it's not the special part, right? What our elephant friend really wants to do is go back here, they want to use this much broader set of data that's in the cloud, as well as the analytical capabilities of DuckDB to actually learn more things about their transactional data. So elephant as manager of this lovely watering hole, would like more animals to come to their place. So what they're going to do is they're going to run a query. Actually, let's run a query here, which is going to say, for the kinds of animals that come to Muddy Hollow, what other places in the world do they like to go to? So use that larger data set to start gaining more insights about the data that they have locally. So if we do that, we're going to see that turns out for animals that go to Muddy Hollow, they actually even prefer to go to Mango Beach. So now our elephant is going to go put up some billboards by the side of the road to try to encourage people to come back instead. Excellent. So that's our demo, right? We've gone and we've shown how we can use DuckDB running in all sorts of different, hopefully creative places to really get the best of all of these tools combined together. Awesome. So just wrapping up and moving us forward, big data is dead. Long live small data, right? With the laptop in front of you, you can do a whole heck of a lot of work. And sometimes you'll need a bit of extra resource, but start with that laptop, start with the belief that, data isn't fearful, it's not big, it's not scary. And then when we take what DuckDB can do and use the cloud to augment it, not replace it, right, but augment it. So we're able to use the resources that we have locally, get some more bigger VMs in the cloud if we need them. We're able to use our data and share it with people, collaborate easily, but still get all that interactivity that we want in our browser, in our interactive analyses. So yeah, that's what I've got. I hope you're interested enough to go check out some of these sites and learn more. We've got MotherDuck, Mosaic, PG-DuckDB, and also a quick shout out, there's a small data conference in San Francisco at the end of September for folks who really want to live the spirit that big data is dead, long live small data. All right, thank you so much. Questions?
Thanks for the great talk and the demo. Let's open it for a Q&A.
Hello, I have two questions. First, how do we ensure performance of a query in laptop? For example, I'm from Power BI team, and customer initially they use small data, but in production the data will grow, and then they will come to us saying, "Oh, your software is broken." So how would MotherDuck solve this scenario?
So I think with MotherDuck, you're paying for the amount of compute resources that you're using. So we bill you for the compute CPU time and the storage. So that we'll do the work to scale that across different VM sizes, right? So you don't have to worry about that. You'll only pay for what you use, but the idea is you can offload that to us. Now, there will be queries, right, at the far edges of things that won't scale, but we think that cliff can be significantly far out, that for most use cases, it's not a problem. Like when the data analysis that Jordan did to decide what's big and what's small, his definition of big data was anything over 10 terabytes, right? But that is such a tiny fraction of the kinds of the data that people process that you can get quite far. And then, if you ever hit the cliff, you need good error messages and so on.
Thank you. I'm very excited about some of the stuff y'all are doing with like hybrid execution. And
yeah, we're trying to rename that. You heard me slip up. It's now dual execution, but hybrid.
Very cool. So right now, as far as I understand, it makes like a temp table locally as it pulls it down, and Mosaic is working off of that. What are your plans for how you might deal with these kinds of data cube indices as they span across both the dual execution models? And are there sort of plans for how you might integrate the Mosaic or MotherDuck WASM clients to handle that kind of on the back end or locally or somewhere in between?
So I will also point out we've got some of our experts in this around here to catch you during breaks and so on. But I think there's really two things. Like on our side, our caching mechanisms are still pretty simple, and we will be improving those and building those out. And then right now, we're not interacting with the data cube. Like Mosaic is its own clever thing, right, with its own way of building and representing these visualizations. And we haven't yet started to explore what would happen if we shared information with a tool like that about how it's using and constructing its data. So I think there's lots of opportunities there for us to improve stuff.
Cool. There's a question here.
Hi, thank you. So I really like your first demo. Like you have like 5 million rows of data in the browser. But could you share me or little bit like how are you going to insert like 5 million rows of data into the DuckDB browser, or like am I missing something on that?
So what it's doing is running part of that query in the cloud, right? So it's not bringing all 5 million rows
Oh, so the data is
over.
actually on the cloud side.
Right. So sorry, I should have been clear with that. Yeah, if I go back to my demo over here, you can see my Duck friend attached the Mosaic sample data sets here. Right. So these are actually located in the cloud. Yeah.
In cloud, like let's say on AWS or like
These ones are hosted in MotherDuck, but yes, they could be. So they're in a DuckDB format hosted in MotherDuck.
I see. Okay, cool. Thank you.
Yep.
Thanks. Any more questions from the audience?
Got one up front, a couple up front, maybe.
You win.
Here you go.
Thank you. This is really cool. One question I had is how is this kind of MotherDuck integration going to be packaged with PG-DuckDB, or will that maybe work with some of the common managed Postgres services like RDS initially, or will that maybe take some time?
It's a great question. I don't know all the details on that one. I would suggest you ask Joe later.
Sounds great. No, thank you.
You're welcome, Joe.
My question is on PG-DuckDB and embedding it in your using it as a Postgres instruction. Is the kind of vision there to replace, like, instead of running a DuckDB server separate from like your Postgres server, just like run them all in one place and not need to have two concurrently?
Yeah, exactly. So you're actually running DuckDB inside Postgres in a process.
Oh, awesome.
Yep. Excellent. All right, thanks so much, folks.